All right, physics lesson 3.2, graphing acceleration. What we got here today is first, let's do a quick review. Velocity, the rate at change in position. So the slope of our position time graph equals our velocity. Now, with acceleration, the slope of a velocity time graph equals our acceleration. So that should have been a review from 3.1. So what that means, if we look at these two graphs, over here we have a position time graph, and over here we have a velocity time graph. So with this position time graph, we can see our position hasn't changed. Our constant velocity of 0, our position hasn't changed. Here, we have a constant velocity, but our position is changing. So that's going towards the negative, that's going toward the positive. So this was the second chapter that we were doing. Now, we're dealing with changing velocity. Since changing velocity is acceleration, if we were to graph velocity, meters per second, over time, normally going to be seconds, then the slope of that is acceleration. So here, our velocity is changing. Here, our velocity is staying the same. Now, here's an important thing to remember. When you have a flat line with a position time graph, your position isn't changed. 10 meters, after 1 second, still at 10 meters. After 2 seconds, still at 10 meters. That's great. But with a velocity time graph, if our velocity is constant, that means it's constantly moving at 60 in this case. So every minute or second that goes by, we are looking at this rate. So your position time graph would be different. It would continue to grow. So let's do some quick practice. Calculate the acceleration from the following points. So let's do A and B. So with acceleration, remember our formula, acceleration equals velocity final minus velocity initial divided by time. Actually, why don't we do C? C is a little bit trickier. So we're looking for our acceleration from point E to F. So we're looking at acceleration there. So our initial velocity at E was 40 meters per second. Our final velocity is 20 meters per second. And the time change is from 8 seconds to 10 seconds. So delta T equals 2 seconds. So when we go to figure out our acceleration, what we end up having is 20 minus 40 divided by 2. And you should get negative 10 meters per second squared for an acceleration. So how much our velocity is changing, what this is saying is our velocity is changing by a negative 10 every second that time goes on. All right, so let's take a look at this. So this is another velocity time graph. What I was hoping for you to do if you were in class was to identify positive velocity or positive acceleration, negative acceleration, or no acceleration. So positive, negative, 0 acceleration. Now remember, if you have 0 acceleration, that means your velocity isn't changing. So if you're going 8 meters per second, you continue to go 8 meters per second. You have not stopped. You are continuing going at the same rate. All right, that brings us up to 3.3. I think I'm going to stop here and do a new video. All right, have a good day.